to find the adjoint of a matrix. Now, using a 3 by 3 matrix, in case you miss our lessons on matrices, we'll place links in the description for each of the lessons we have done on matrices. Now, let's get started with using this example. The adjoint of a matrix itself is actually the matrix of the transpose of the cofactor of that matrix. That is, if I have matrix A and I'm looking for the adjoint of matrix A, the adjoint of matrix A will be the transpose of the cofactors of matrix A. So that is, for each of these elements of matrix A, I'm going to look for the cofactor for that element. Now, in case you missed our lesson where we explain cofactors of matrix, please do not hesitate to also check the description below. We have explained how to find the cofactor of a matrix. And to ensure you receive our lessons anytime we create them, kindly do not hesitate to subscribe to our channel so you'll be sure to receive our lessons anytime we create them. First thing we're going to be doing is to look for the minor of this matrix, and then we'll now find the cofactors of that matrix simply by attaching signs to the minors of that matrix. The signs we're going to attach for 5 is going to be positive, 2 is going to be negative, 1 is positive, and here I'll have negative, here it will be positive, here will be negative, here also will be positive, negative, and here will be what? Positive. Let's look for the cofactor of 5. I'll tag it as A5. A5 will be, it will come from plus, and I'll pick all the elements that are not in this line, that are not in the line of 5, that are neither in the rows nor on the column. That will be 1, 6, 4, and 3. So that I'll find their determinant, so that this will be plus 1 times 3, that's 3, minus 24. That will be the same thing as minus 21. The next thing will be to find A2. For A2, now I'll still pick this row for A2, then I'll pick the column along A2. Now the sign on A2 is negative, so that will be, I'll have the determinant of 3, 4, 4, and 3. So that will be the same thing as minus 3 times 3 will be 9, minus 16. So that will be equals to minus 7. So that's the same thing as plus 7. Now we'll do the same thing for A1. Means we'll be picking all this row 1, and the third column. Row A1 is positive. That'll come from 1, then I have 3, 1, 4, and 6. That equals to plus 3 times 6, that's 18, minus 4, which is equals to plus 14. Now the next will be A3. That will come from the sign on A3 is negative. So my determinant, I'll pick rows and the column. I'll be left with 2, 1, 6, and 3. So that this will become minus 2 times 3, that's 6, minus 6, that's equals to 0. Next will be A1. A1 is on the second row and also on the second column. It's positive. The sign on A1 is positive. The elements I'll be picking will be 5, 1, 4, and 3. So that will be equals to plus 5 times 3 is 15, minus 4, which is equals to 11. Next will be A4. A4 is negative. The sign there is negative. So the elements I'll be picking will be 5, 2, 4, and 6. So that this will become negative into 5 times 6, that's 30, minus 8 is equals to minus 22. Then in the last row now, so I'll be picking A4 again. This 4 now is on the first column and the last row. So this will be plus. There's a 4 here. So we're picking this row, this column, and this row. So the elements will be left with 2, 1, 1, and 4. That becomes to plus to 8 minus 2, which is equals to plus 6. I'll pick A6. I'll come from that's the third column and the third row and the second column. So that's negative. Then I'll be picking 3, 5, 3, 1, and 4. So that will come from negative into 5 times 4, that's 20, minus 3, which is equals to minus 17. Then I'll pick A6, A3. A3 is the last element, that's plus, and that's 5, 2, 3, and 1. So that this is equals to plus 5 minus 6, which is the same thing as minus 1. Let's arrange our elements into a column. Let's take our elements into a column. Let's arrange our elements into a matrix. On my matrix, which is matrix of the cofactors, C, let's describe it as C, will now look like the first elements are minus 21. First element will be minus 21 plus 7 and plus 14. Minus 21 plus, that's minus 21 plus 7. And let's make up our matrix. C, that's the matrix of the cofactor. This will come from my first element. Let's check the first element. That's minus 21 plus 7 and plus 14. That's minus 21 plus 7 and 14. I can write them without the signs. The second set of elements for the second row, that's 0. That's for A3, A1, and A4. That's 0, 11, and 22. Minus 22. That's 0, 11, and minus 22. That's 0, 11, and minus 22. And the last pole is 6, minus 17, and minus 1. That's 6, minus 17, and minus 1. The adjoint of this matrix, like we described when we started the lesson, the adjoint A of this matrix is the same thing as a transpose of these cofactors. The transpose of these cofactors, we explain this when we dealt with transpose. I'll use a lesson on transpose as our end screen, and I'll also place it in the description below. Now, this is minus 21. The rows will become the columns will become the row. So I'll be making the first column here to become my first row. This will be minus 21, 0, and 6. Next to be 7, 11, and minus 17. Next to be 14. That's the last column now. I'm making the last column to become my last row. Minus 22 and minus 1. This, you now understand how to find the adjunct of the matrix. In case you are yet to subscribe to our channel, please do not hesitate to hit the subscribe button. That way you'll be sure to get our lessons anytime we create them.